Thanks for being back. So now hopefully the more relaxed part starts. Next up is a broader discussion. It can be about single ManyBabies projects or the overall idea. And to get this discussion started, we have a short presentation by Sridin Lavelle. She is a philosopher and has been tracking what ManyBabies is doing and has been evaluating what is going on here. And what I particularly like is her, I would say, positive or optimistic perspective on what is going on there. We've seen it in other fields, a lot of bad vibes between original authors and replication people, not finding anything, a lot of fights and not a good working environment. ManyBabies takes this constructive approach to learn more and get more about this and promote advances of the field. And Srilin adds to that perspective and thinking about what can we learn from, even from stuff we don't know, and how do we proceed with that.
Thank you very much. It's lovely to be here. I've never spoken at a psychology conference before, so this is a bit nerve-wracking. So as Toby said, I'm a philosopher, and at the moment I'm engaged in a lot of philosophy of science. I'm really interested in how replication failure is panning out, particularly in developmental psychology. Why developmental psychology? Well, my starting premise is that you can have people doing really good science who know what they're doing and who are contributing and bringing more knowledge into the world, even in fields when there are high rates of replication failure. So I don't think that high rates of replication failure are necessarily indicative of bad science, and I think I'm preaching to the converted here, if you're here at the ManyBabies talk. But this raises interesting questions about how do we develop arguments to support that view? How do we develop alternatives to kind of the more conventional or perhaps the more well-known brute force arguments that if something doesn't replicate, then we just chuck it out and it doesn't work? And that research project has split into two questions. One question is, why do some fields have high rates of replication failure? And again, I've been looking at this sort of within the lens of developmental psychology. And the second question is, how do we evaluate research programs which have high degrees of replication failure? How do we know when we're making progress? What should our criteria be for when we give up? So I think there are some fields where there's lots of replication failure, and that's fine. And I think developmental psychology is an excellent example of one of these. So for this brief introduction, for the discussions that follow, I'm going to focus on the second question, how we should evaluate research programs that have high rates of replication. And I'm going to focus on this, but if later you want to talk to me about other parts of my work, so many questions have come to me this morning listening to the amazing research that's going on. So please come and talk about it in the discussion or coffee later. But I will just say a few words about this first question, why we should expect lots of failed replications in developmental psychology. Well, we all know babies are difficult and expensive, so we don't get very many of them to test. And something which really came out in Judith's talk just before is that many of the techniques that we're using are only a few decades old. Now, you might think, okay, 40 years, that's a long time in developmental psychology. You might even argue that kind of the study of infants as we know it has only been around for 40 years or 50 years. But in contrast to the older sciences, the more mature sciences, as people refer to them, like chemistry or physics, it's a blink of an eye, it's nothing. And so, as such, there are fewer effects that we're absolutely confident about. There are fewer kind of robust things that we know absolutely should be there. And again, this is okay, these are descriptive claims. We would expect that from a relatively young field. So just to take an example that I use in one of my papers, if you get a sweet, a Mento, you shake up a bottle of Coke and you put your Mento in and it doesn't froth everywhere, what has gone wrong? So I actually asked this I was doing a talk in Dundee, which is a small town in Scotland, and I said, has anyone done this? And this wee boy put his hand up and said, yeah, I've done it. I said, what happened? He said, nothing. I said, oh dear. Do you think you found a gap in the laws of physics? Or do you think you found something new that could contribute to chemistry? He said, nah, my granny's Coke is always flat. And he said it with such a look of resignation that this is always what happens when he goes to his granny's house. But even this 7-year-old boy recognized that there are some robust effects that we expect to be there in physics. And what had gone wrong wasn't that he discovered some new law, but that something had gone wrong with his experiment. So there's a very robust effect there. Now, in younger fields, we have fewer of those gut instincts or fewer of those sort of unshakable tenets. I think the closest we get is, that I can think of, is probably elicited false belief tasks. Even if you disagree about what that effect means, if you have a study that isn't showing kind of the right responses in 6 or 7-year-olds, something has gone wrong with your study. I mean, that's something that's been replicated so many hundreds of times. So instead, what I want to talk about now is how we should evaluate research programs that have high rates of failed replication. So progress is important for the scientific method. We need to have some understanding or some criteria for when we're making headway in our knowledge, when we're gathering more things that contribute to our field, that contribute to science, and when we're not, when we're just chasing down a rabbit hole. And the classic method for evaluating progress that is most well known among psychologists, at any rate in my experience, is Popper's falsificationism. So we want our theories to be falsifiable, and replication is one of the key ways of managing this. If you get a failed replication, then you falsified the theory that you're looking at. But falsification, so this is going to sound really mean to psychologists. Psychologists, in my experience, look up very highly to Popper. Philosophers of science moved on from Popper about 30 years ago. And I think one of the reasons is that falsification as your kind of ultimate goal, your one criteria for evaluating research programs, is problematic for many well-rehearsed reasons. But I think it's especially problematic when you're working in fields with many unknowns. It's especially problematic when you're working in fields where we just don't know very much about what we're researching. And so we need to look, I think, again, developmental psychology, infant psychology, is an example of one of these fields. It's an example of where there are lots of things that are uncertain. There are lots of things that we don't know. It really is a very new field. I mean, we're using NIRS as a technique that's only been around for like 5 or 10 years. So we need to rethink what sorts of frameworks we're using to evaluate progress, one that is better suited to those fields which have high degrees of uncertainty. And the position that I endorse is one from the philosopher Hasok Chang. And he puts forward a framework called epistemic iteration. And I'd like to spend the rest of this kind of introduction talking about epistemic iteration because I think it's a really helpful idea. So epistemic iteration is Chang's answer to the question of how a field can progress when there's a lot of uncertainty in it. So Hasok Chang begins with a puzzle. He says, how is it that we can start from a really bad starting point because we don't know what we're doing and get somewhere better? So he's against the kind of old philosophical views where you have to start on the knowledge that you know, and it's certain, and build up from there. Hasok Chang says, well, if you do that, you're never going to get anywhere because we could question everything. So his case study, he looks at temperature and the historical development of thermometers. And the reason is because about 200-300 years ago, we needed better standardization of how we measured temperature, but we didn't have a very good starting point. The best starting point really we had was our senses, our hands. So how did we get from lots of scientists just having a rough and ready idea of how hot or cold something might be to the finely graded thermometers that we have that emerged kind of within that 200-year period. And so Chang's argument is that even when there's a lot that we don't know, and even when we're starting from a bad starting point, i.e. just what our hands can tell us about whether something is hot or cold or warmer or colder, we can nevertheless take that relatively uncertain starting point and begin to build outwards to something that is more certain. But how does that happen? And he says that this happens through a process that he calls epistemic iteration. So it's a process in which successive stages of knowledge, each building on the preceding one, are created in order to enhance the achievement of certain epistemic goals. In each step, the later stage is based on the earlier stage, but cannot be deduced from it in any straightforward sense. Each link is based on the principle of respect and the imperative of progress, and the whole chain exhibits innovative progress within a continuous tradition. Iteration provides a key to understanding how knowledge can improve without the aid of an indubitable foundation. We throw very imperfect ingredients together and manufacture something just a bit less imperfect. And so in a paper that's just been accepted, I've been using this concept of epistemic iteration to apply to the ManyBabies 2 project. Having listened to the talks today, I think it's such a rich framework to help us understand what's happening in many of the other ManyBabies projects. But I'm just going to talk you through some of my thoughts about how this applies to ManyBabies 2. So with ManyBabies 2, we started with a double puzzle. We wanted to know whether infants reliably looked to where an agent would search for an object based on the agent's false beliefs. So we had uncertainty about the phenomenon. The whole reason we're studying this is that we don't know whether infants can track false belief. That's why we're asking the question in the first place. But there's also uncertainty about the measurement. Is anticipatory looking the best way to tap this phenomenon? And I think this comes out particularly well in the kind of exchanges in that special issue that Toby and many others contributed to in the commentary, where you had people like René Baillargeon and also Victoria Southgate saying, infants can track false belief, you've not implemented the anticipatory looking paradigm correctly. That's kind of a broad brushstroke. And other people saying, no, anticipatory looking is working, but they're not tracking false belief because infants can't track false belief. So when you have a puzzle like that, how do we begin to disentangle it? How do we pull apart the working parts? And so let's turn to Ha-Seok Chang's idea about the principle of respect. So he says that we start with our bad starting point, but nevertheless, despite that starting point being bad, we have to respect it. So the first thermoscopes, the first things that were kind of there to measure relative temperature, needed to reflect our folk intuitions, our everyday intuitions about things that were hot and things that were cold. So it had to show that fire was hotter than snow. Maybe it had to show that bodies are warmer than stones. So if someone had built a thermoscope which routinely showed that a stone was hotter than a person's body, you would say, no, 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 something's gone wrong with the way you're measuring that. You need to go back to the drawing board and build a better thermoscope. So although our folk sensations are a bad starting point, we still have to respect them because they're the only starting point that we have. But then from building out from there, we can get to self-correction. So to begin with, people were building these things which were measuring temperature, and once they started to respect our folk intuitions, once you got something that roughly tracked what we thought things were that were hot and cold, you could then use that for self-correction. So if you have a hand that's been inside your glove and it's warm, and a hand that's been in the snow, and you put your hands into a bucket of water that's tepid, one hand will feel the water as cold, the other hand will feel the water as hot. And you could use this thermoscope that you've built to show that actually the temperature in the bucket is the same throughout. So there you've gone from something that respected the folk intuitions, this machine or this instrument that you're building to match our sensations of hot and cold, to something that can then go back and correct our folk intuition, something that can say, no, no, although your folk intuition is that this bucket of water is a different temperature, this thermoscope can actually show that it's correct. So how does this work in infant psychology? Well, we start with imperfect knowledge. And something that we've seen in the ManyBabies too is that our imperfect starting point is goal attribution. So we're pretty confident that infants can attribute goals to each other. And one of the reasons that we're confident is that we have multiple lines of support for it. We have lines of support from evolutionary psychology, from non-human animals, from other paradigms that are used, and most, it shouldn't be dismissed, folk support, what caregivers through the ages have told us. So how does this help? Well, yes, you have a foundation that's imperfect, but you can use that to start to calibrate the anticipatory looking paradigm, the other part of the puzzle which we weren't sure about. So if anticipatory looking doesn't reflect that infants can track goals to each other, at that point we can be relatively confident that something has gone wrong with the anticipatory looking paradigm, because we need to respect our kind of starting point. We need to respect our intuition, which is imperfect but relatively stable, that infants should be able to attribute goals to others. And that's exactly the story we see in ManyBabies too. You build your stimuli, you make sure that they are tracking, or that babies are able to track goals from it, and then with the minor modifications, you can build outwards from that to the things that we're much less certain about, to things like knowledge and ignorance, and ultimately, maybe when we've cleared all this to false belief, who knows, that is a goal. So how do we understand progress? So Hasek Chang says that if we're seeking to build a new standard, that's because we want to do something that can't be achieved by the means of the old standard. Why do we need thermometers? Because 200 years ago, chemists were wanting to do experiments that required much more detailed analysis or a much more detailed standard of measurement than they could currently get with the instruments that they had. They weren't happy with the ones they had to move to a better place. But if every attempt to move on contradicts what we have already, then we have to step away and we have to say that we should be abandoning this paradigm. So hypothetically, this didn't happen, but this is a hypothetical situation. If we couldn't generate any stimuli for anticipatory looking that showed goal anticipation in infants, that would be a pretty good reason to say we've got self-contradiction within the system. We have to ditch it all entirely and just start afresh. And then there's problems of ecological validity, which I won't go into now, but these are two highly recommended papers on that topic. But the second important part of progress is what's known as enrichment. So when the new process builds on the old rather than outright contradicting it. So again, this has happened with ManyBabies. We're confident with the goal anticipation stimuli, so that allows us to move into more uncharted waters about knowledge and ignorance. We can use that for phenomena that we're less certain about. So we've been able to take our methodology and extend our use of it in ways that we are more confident about. The final point I want to make about Hasek Chang's analysis is that he stresses the idea that there are always multiple epistemic goals in play with our scientific projects. And again, this goes against Popper. So Popper had one epistemic goal, falsification. That was the only thing that we should be aiming for. So if you like, Popper was aiming for, when we do experiments, we are testing a hypothesis. And that's the only thing that we want to do, is test the hypothesis. But I think replication, and particularly what we see in these labs, is a technique for achieving many epistemic goals and not just the testing of a hypothesis. When you have multi-lab collaboration, you can improve the standards of measurement that you're using. You can get better standardization so that other people, we are all using the same, pardon me, same standards. We can increase our confidence in a particular methodology. And then something that really, really came out in Francis's talk, which I've written about elsewhere, which we can talk about here later, is experimenter skill. So something that I think Francis highlighted is there's so much skill in being able to get results out of babies. René Baillargeon can get results out of babies because she's one of the most skilled people in the world at getting results out of babies. So much of that skill is tacit. It's not written down in journals. It doesn't come out till you do the video walkthrough, for ManyBabies 2. How are you welcoming babies into the lab? Is that putting them off? And so another epistemic goal could be making tacit knowledge explicit, things that we didn't know were important, things that are embodied in our skill. And again, that's something that philosophers of science have looked at a lot. There's an interesting literature, and I think this is such a fruitful place to apply that, understanding the role of experimental skill in getting knowledge. And finally, multi-lab collaborations help us know about the unknowns, the Donald Rumsfeld's known unknowns and unknown unknowns. We get a better understanding of our ignorance, and understanding where the gaps in our knowledge are is critical for moving forwards. Now, some people might say that this is an overly liberal view of scientific progress, but I disagree. I think progress can, in some cases, and particularly again in new fields, progress can be characterized by drawing the boundaries around what we know and pointing out the gaps and the holes of the things that we are less certain of. So epistemic iteration as a framework, I think, offers a way of looking at the replication work in infant psychology that highlights the vast epistemic gains that are being made. But we need failed replications to show us the gaps. Importantly, we needed our first passes. We needed our kind of like messy replication attempts of false belief work to understand that there were problems with our understanding of the phenomena and the methodologies in place. And finally, and this is at the very core of my research project, high rates of failed replications are not necessarily indicative or diagnostic of deteriorating research programs. I think what I'm trying to do in my work is show all the wonderful things and all the progress that can be made through looking at these failures. So here are some questions that I thought might spark discussion. I'm sure you have other questions too, but I'll just leave them up for now. Thank you very much.
Thank you very much, Sulin. Do you have any questions direct to her? If not, then, yeah, Jonathan?
So, in terms of the question about criteria for stopping, one thing I've thought about sometimes is what's the difference between a reliable result and a meaningful result?
Okay, say a bit more about that.
So, what's the point at which you can get a very reliable result in the sense that, 54% go one way and 46% go the other way, but that happens 95% of the time. But is that a meaningful result in terms of understanding how the mind works?
Oh, I understand. Yeah, I think that's a really great question, and I think that ties back to some of the issues of ecological validity that we were talking about. So you could get a result that's super reliable and super robust in the lab, but perhaps could be described as fragile, in that the conditions have to be just so in order to get that. And there's different ways of working outwards from that. So I highly recommend Uliana Feast's paper about this, where she talks about fragile effects, because she stresses the point that every experiment that we do, even the ones that don't use high-tech experiments, you're always trying to cut out the noise. So that's a feature of how experiments work. So if you want to say, well, it's not a meaningful, it's not an interesting result because you need all these criteria in place in order to get it, you still need justification for, well, why is it there? And once you've got to that point, then you can start to work outwards to perhaps sort of fitting it into your broader theory. So what does my theory predict? Why does my theory predict these results in these very specific circumstances? What can we strip away, or what can we add in terms of noise for that still to remain robust? But that's that's one of the questions right at the heart of particularly developmental psychology, where you're working with very apparently unnaturalistic looking stimuli to get the results that you want, but that's the only way you can get them.
Can you say something about how does this process of epistemic iteration
Great. Yeah, there's only so much I could fit into 20 minutes, so thank you for that question. I think there's the similar idea with your theories. So again, your theories need to start from somewhere, and that point could be bad. In a field where there are many unknowns, that point will necessarily be bad, but you still have to build up. So it's that idea of when can we be. I think this is why I think tracking the gaps in your knowledge is very important, because you need to figure out whether the theories that you have can accommodate those gaps, whether those gaps are predicted by the theory. Where are the hard walls? Where do you get to a point where, we really didn't expect that reversal in the data, or we really didn't expect to have no effect at all? Do we kind of reassess our theory within the broader cognitive development? And I think this kind of fits in with kind of the Thomas Kuhnian idea about unification about theories. So it helps us think a little bit more about how does my theory fit into the broader cognitive basis? And am I shedding questions on a more foundational level? So let's take as a foundational level, say, representational theories of mind versus embodied theories of mind. How does my theory fit? How does my kind of theory fit into that? Am I working at a mid-level theory, or am I working at a theory that's extremely specific? So to go back to Jonathan's question about one phenomenon that needs lots and lots of criteria in place for it to work. So naturally, there's always this very close tie between data and theory. Data is theory-laden. You won't be able to see the data as data unless you already have certain background commitments. This is a tangent, but it's a question I've been wanting to ask all morning. Is there's so much data being collected with ManyBabies? How can we be responsible, or how can I think one has a responsibility to make sure that data is available to as many people as possible, because it's expensive to use, and it's expensive to collect. And this is one way in which you could allow people who are less represented in the community to apply their theories, to look at that data with their theoretical background and to literally see different things in it, because we know, again, from the philosophy of science that happens. So data is theory-laden, but so data is theory-laden. There will be gaps in your theory, there will be gaps in your data, and it's about reconciling those to figure out where your boundaries are. Sorry, that's a very vague answer, but we can talk about it more later as well.
Any further questions or comments, maybe on that topic or in general the whole workshop? Yeah?
I have a question that is related to what you just talked about, but maybe more addressed to other people in the project. I'm a Spanker. I knew absolutely nothing about this project, which seems extremely interesting. And I wondered precisely, because we talked a lot about how to improve knowledge in cognitive science, developmental cognitive science. I come from the study of language, and I don't know if it's the same in other, let's say, sides of cognitive science, but in the developmental or not even developmental study of language, a big problem is also, let's say, I might say schools divisions, or anyway, let's say radically different vision about what language is, and so, of course, how it develops, which sometimes creates some kind of lack of communication and lack of exchange, so it brings to a very, a great difficulty in that cumulative knowledge accumulating and so on. So I wonder if this was also like something that you, I don't know, take into account while developing the ManyBabies project, if you have people which come from different backgrounds or same background but looking at the same problem through very different perspectives.
Maybe I can, that's a really important point, maybe I can use ManyBabies 2 as an example here. So the ManyBabies 2 consortium consists of, I don't know, you could call them believers and non-believers, or rich interpretationists and lean interpretationists, original authors and non-replication authors. they have been and are still more or less on board, and this is what makes that's what's called adversarial collaboration. So you put people with from different theoretical camps on one table. They all agree on one paradigm and all say, okay, findings we get from this study will be meaningful, because the other solution would be your paradigm can't measure what I found 10 years ago, and then we have no or little basis for going on. That's the hard part, and this takes very long, which is why I mentioned that it took us 2 years to get to that pre-study I showed. And that's what makes it hard on the practical side for early career researchers to get something out of it, because processes might take quite a while. I think it's really important, and this is the most fun on the other hand, to have these arguments, discussions via Zoom, all those different perspectives, but people are still talking. I guess that's the difficult thing, but when you have this, then the outcome will be good. So get people on one table and talk to each other, even when they fight and have argument, but make sure that they stay on the table. Yeah. I don't know how bad it is in your field, but always invite people, value every opinion that is out there, and try to make something meaningful out of it. There are other ManyBabies projects. Some are less controversial, some are very controversial, like the neonatal imitation, which is coming up. I don't know. Help Us and Hinder Us is kind of the same, again, but different perspectives.
Yeah, I think so. For the helper and hinder, for better or for worse, the approach is almost the opposite of ME2, where as lead researchers, we had a really strong, we kind of just made this thing up and sent it out like, this is what we think, like most closely replicates the original finding, right? And I think this goes back to the different kind of objectives that ME4 and ME2 are trying to tackle. ME2 is trying to answer, in some ways, the more zoomed out question of like implicit theory of mind, like can they do it, right? And so the way to measure that is not agreed upon, and that's why there's this importance of like getting everyone involved, kind of finding common ground between people who think and can't. Whereas ME4, the initial idea was to like, we were just going to pick one of the case studies, and it makes sense to pick like the original findings that kind of sparked this line of investigation. And we're just going to see if this particular version can be replicated on a large scale. So I can't really say if either of these is in a vacuum better or worse than the other, but they seek out to accomplish very different things. At least that's my perspective. And I think maybe, like, now that I'm thinking about it more, maybe ME4 is the exception rather than the rule, because I think ME3 took a more collaborative approach as well as making use in that way.
Yeah, I can indeed add to that. I think MB3 is a little bit in between MB2 and MB4 in that sense, in that there were some degrees of freedom that we had as a team in designing the study, not as many as I think MB2 had, but definitely more than MB4. As in, we wanted to replicate the original finding, the Marcus finding, but we also agreed as a team that there were some flaws in the original design that we needed to repair, basically, right? And many people agreed that that was the case in terms of the stimulus material, but also in terms of the timing, some of the phonological properties of the stimuli, etc. So those were redesigned, but not the original setup of the experimental procedure. That was basically a replication in that sense, right? So we have a little bit of a middle ground there.
You also had like comparable background ideas, because sometimes like you can more or less agree on the fact because it's solid, it's robust, it's been replicated, but maybe you disagree a lot about what it means, what it implies
I don't think so, and I also don't think it's particularly necessary, right? So I don't think all of the researchers in the ManyBabies tree collaboration agree on how we should interpret this phenomenon of rule learning, right? Whether indeed you could interpret it or attribute it to statistical learning processes or to some other processes. To some extent, that those questions come after the fact, after you have established that it's a robust effect, and everyone in the group agrees that we need to establish whether it's robust or not, and then we can move on and see, like, you know, how do we interpret this? And so I'm pretty sure that the group, we didn't talk about it like a whole lot, because we were sure, like, there's dissenting opinions about this, but we do agree, like, on, you know, the necessity of establishing the robustness.
Innateness person to the other side and say, can we come up with an experiment that would ultimately show who's right, and then do a ManyBaby study. So it's actually a very good idea. Yeah.
Just a follow-up question. Does that bring challenges for like publication? Like you decide, I guess for a publication you always have like a theory that is guiding the interpretation of the results, and if people are coming from different theories, how do you, like, I haven't read the publications that you're preparing, is that a challenge too, or?
So I guess this hasn't happened yet in ManyBabies, I'm pretty sure that, but there are other examples of adversarial collaborations where people differ in their discussion. So Camp 1 writes first half of discussion, Camp 2 writes second half of discussion, and there's in the end some conclusions, so you don't have to end up with an agreement. It's okay to still be in different camps. That's possible.
Yeah, I think also in the introduction for MB3, you can just, let's say, show the diversity of backgrounds or theoretical environments where this phenomenon of rule learning or statistical learning, where it plays a role, without, you know, valuing one over the other, but just showing the diversity of perspective that you can have on this phenomenon without picking any side.
Any more questions or comments? Also, practical side. Yeah?
Yeah, I would ask a question from the theoretical side, if I may so link to the last talk in the philosophy of science. Yeah, so I thought that was really interesting. Thank you very much. I feel like it really related to the prior talks, and it really got me thinking about the spinning. So I was interested in this aspect of, especially which was mentioned on the talk, especially of how everything on the one hand needs to be standardized, but on the other hand, it can be interesting to allow for some variability between labs. And then the way you framed this as, on the one hand, we need experimental rigor and we need to make sure we standardize things, but on the other hand, does this lead to fragile effects? And so I'm curious if you could speak more on that. Is there an inherent tension between experimental rigor and generalizability, and if so, how should we combat this? Is the idea that we need to introduce more variability, more experiments that are in themselves incredibly standardized?
Yeah, so like in the kind of late 70s and early 80s, philosophers of science were trying to figure out what are the most informative types of replication that we could do. So if you're doing a replication using so this was done in like chemistry, exactly the same samples in the same lab, maybe 10 minutes after you've done the first one, well, that kind of seems to be reproducible, thinking about Toby's chart that he had up earlier. And something that is kind of sociologically true is that a successful replication gains more weight when it's done in someone else's lab. It gains even more weight when it's done in someone else's lab who doesn't believe the effect is there. So there's a very sociological kind of aspect going on here. And some of that, I think, extends beyond the science itself to the sociology of the science, the trust in the other people who are doing it. How much do you trust that lab? Oh, well, you know, they share a funding body. It's in their interest that they successfully replicate. So it's about, on the one hand, we need to think about what those social aspects are. And I'm not saying that we can fix them, we can't. But awareness of those social aspects is step one in like recognizing your biases. Why do I trust this successful replication more than I trust that one? What's driving that intuition? So being reflective upon yourself about how you're thinking about it. The more interesting and bigger question about the fragility of effects, well, I think that's something that psychology, I think, not sufficiently acknowledging how fragile effects are in psychology is in a large part responsible for this perception of a crisis in the field, because so I have other work thinking about this, but I think partly due to Popper's falsificationism, so Popper was very mean to psychoanalysis, particularly in the UK. Since Popper's work, there weren't any psychology departments. They were all experimental psychology departments. And it was important to put that word experimental in there to say, we're not psychoanalysts. We're not doing the stuff that Popper thinks was bad. We're doing good stuff. We're doing science with experiments, and that makes it science. But in so doing, that perhaps has put premature kind of limitations on the methods. So it's kind of pushed some psychological fields into a very rigorous cycle of hypothesis, test, in order to kind of show that they're not part of that disrespectful, disreputable part that is psychoanalysis. But perhaps it's too soon for a newly emerging science to take on those strictures. How does that fit? So that kind of fits in with the fragility in that I think there hasn't been as much acknowledgement of how fragile effects are, and perhaps not as much acknowledgement about how generalizable we should even expect results to be. And again, this emerged from Joseph Henrich's seminal paper in 2010 on weird participants. That kind of brought that to the fore, like how much should we be expecting sort of very westernized hypotheses to generalize. So I think these are questions that they've grown out of the replication crisis because they're sort of partly at the root there, but they are kind of broader methodological questions that psychologists and philosophers of science need to think about. How do we think about fragility? All data is artificially produced. Even data in the wild is artificial in the fact that someone had to document it and choose a particular way of documenting it. So it's about acknowledging what is artificial there, trying to be aware of where the limitations are and feeding that into your methodologies. And that's difficult. It's really hard to do.
Looking at the time, we start with the last part of our workshop. Yeah, only if you have some super pressing question, then shoot. Okay, so in this last part, Francis will give you ideas on how to participate.
Oh, we're using this now? Okay.
If you want to.
Yeah, perfect. Okay, great. I like having my hands free. Okay, so when Toby told me to present this part, I didn't really receive any instructions. So I kind of liberally interpreted this as tell people about how you can get involved, but also be honest about helping them evaluate whether or not they should get involved, especially from the perspective of an early career researcher. Just a very quick background on myself. I started in ManyBabies as an undergrad. and it's been 5 years since I joined, and I've received this question actually many times just now during the coffee break. No, ManyBabies 4 has nothing to do with my dissertation and my own work. It's all bonus stuff that that is, that I had to spend time working on, in part out of my own curiosity, and in part because I'm in too deep. So the first half, I'm gonna just go through a little bit about different stages of projects that you can get involved, what that might entail, how you can decide like what part might suit you best, and then in the last part, I want to talk about like how you can start making these decisions, what things to consider, what things you're trying to think about, what you're trying to get out of the experience, and whether or not that cost-benefit analysis makes sense for you. Of course, with an emphasis on we really want early career researchers to join, because early career researchers bring fundamentally different perspectives as compared to maybe more senior members in the community. And I'm going to try really hard to leave time at the end for any questions. So, of course, there are several stages of a project where you can kind of slide in. This is like the 3 main parts when you initiate a project, joining in on data collection, or joining in at the analysis part. There's also other opportunities in ManyBabies beyond being involved in a project that I'll get into, but we'll first talk about starting a project. I'll be completely honest, starting a project is a massive undertaking. It's like Toby kind of alluded to already, not always suitable for like a PhD student, just given the time frame. It's really unpredictable how long a project will go on for. People might spend a few months, and then bam, you have stimuli ready to go, ready to distribute, and you can finish data collection before you graduate. People might argue for 2 years, and you end up having repeated edits over and over again of the same videos. I still remember crouching at like 5 a.m. in a little room on the Zoom call with the MP2 people, and people like fiercely debating like, no, there should be a hole in the tunnel. No, there shouldn't be a hole in the tunnel. There should be a ding sound to signal the entrance. There shouldn't be, little tiny trivial things can end up being very fiercely debated. Probably not a great idea, but the whole process is fairly straightforward. You submit a proposal, you write out like the phenomena of interest that you want to study. There's a lot of benefits. One is you get lead authorship. At least I would hope you get lead authorship if you lead a project. And you get to answer something that maybe your single lab does not have the resources to answer, right? A lot of questions require tremendous sample size to really get a concrete answer, especially if the effect size is fragile. But of course, very big time commitment. It's super long term. Be very careful about whether or not you want to do it. This is mostly so far done by PIs. I think I might be the only grad student leading a project. Well, actually, no, that's not true because Stefan is leading the many webcams. So there are a few instances of PhD students or postdocs leading projects, but it's super doable if you have great project management skills and you're willing to kind of do the extra work. Now, there's a subset of this, which is starting a spin-off project, kind of tagging off of data sets or existing infrastructure of a ManyBabies project. This is still a great opportunity to get lead authorship. Many webcams, for example, is a great success case of a spin-off project. It technically borrows stimuli from MB2. So a lot of kind of the legwork that goes into that is already done, and so you just have to worry about setting up the infrastructure for your own specific question that's related to existing projects. The amount of work will really vary depending on what kind of question you're trying to answer, whether or not the type of work can be automated, and so on and so forth. But this is what I would recommend if you're really keen and you want to get involved as a PhD student, but you don't know or don't think you can handle like the tremendous amount of work that comes with like a full-fledged project. Now, collecting data is where most people kind of jump in. This is fairly straightforward because ManyBabies sets up infrastructure such that you don't need existing expertise in methodology to join project in data collection stage. It depending on the project, your contribution can be as little as 8 participants, because we really try to emphasize lowering the barrier to entry in order to get a more diverse sample. For a lot of projects, that trade-off ends up being worth it in order to not exclude labs with maybe fewer resources, right, for a variety of reasons. The good news is that even if you're just collecting data, ManyBabies places great emphasis on making sure traditionally invisible labor doesn't remain invisible. So we adopted the credit authorship model, where you can report what you did for a particular project. Different projects might have different authorship restrictions, like only 2 or 3 authors from a lab. So just be very careful kind of navigating that, but you can get authorship from just data collection. Make sure you reach out to the project leads. There's lots of ongoing projects that still need data collection. I'm sure they would love to have you. Now, with that said, please think about your resources, both in terms of your own time as well as your PIs. Some PIs might not be on board with contributing to ManyBabies, not because they don't like ManyBabies, but because there's just not lab resources, both either monetarily or time-wise to support you through that. Just so really think about whether or not you can do it, if your PI can support you, and whether or not you can handle the workload. And finally, well, not finally, there's one more. So you can also join at the data analysis step. This is less common, I would say, because typically, or at least right now, both MB2, MB4, and I assume going forward MB3 will be adopting like the register report style of getting these findings published, which means that data analysis plans are often already laid out from the start. So it's hard to kind of join in at the very end. With that said, like Toby mentioned, there's a lot of cleaning involved. So if you have particularly good statistical or skills in R with cleaning massive data sets, or alternatively, if you're really keen to learn these skills and you think this will be something beneficial for your own work, this is a great step to join. I joined the MB2 analytic team back in 2019. I learned a bunch of stuff and then I kind of just left. So I kind of reaped the benefits, and I did help clean a lot of the initial data from the pilot, but then I decided, like, you know, I was kind of promoted to leading MB4, and I decided, like, I can't do everything at the same time. But it's nonetheless a great way to learn new skills. Again, this is on a case-by-case basis. Some projects might need coding instead of analysis. And for example, in the emotion spin-off project, a lot of people, including undergrads, are being trained to do fax coding of babies' facial expressions. As a very unique set of skills that's not really easy to learn, nor is there a lot of resources for you to kind of teach yourself adequately. So that's, if there's a particular set of skills that you're really interested in, ManyBabies is a great way to kind of network and be connected to people who can teach you those skills. Okay, so finally we move on to the other stuff. Like, what if you don't have time to collect data, you don't have the time commitment to do any analysis or coding, and you certainly don't have time to start a new project, but you really like what ManyBabies stands for and you want to still contribute somehow. Well, the good news is that we have started these committees, one of which Ingmar had alluded to, which is the teaching, what is it? Teaching, Training, and Open Science Committee, and other existing ones, such as diversity and outreach, ethics, things that has to do with ManyBabies infrastructure and coming up with policy and building better pipelines for ManyBabies to work more generally. In these instances, prior experience with ManyBabies is absolutely not required. In fact, if you don't have experience with ManyBabies, even better, because you bring in fresh, unbiased perspectives as to how to approach a lot of these issues that we're facing. Early career researchers are especially welcome because in order to, make improvements in policy, the population that you're supposedly trying to benefit. For example, in the diversity and outreach, we talk a lot about how to get traditionally underrepresented and early career researchers involved and benefit from the process. Kind of need the people who are benefiting from the system to tell us like if it actually is a good idea, right? There's nothing worse than a bunch of CEOs trying to make policies for their employees, and it just totally backfires. So this is a great opportunity to join. Very simple, just reach out to one of the community leads, it's all on the website, and ask if there's an opening, if there's anything you can help with. Okay, so now on to the bigger question, which is, should you actually get involved, right? I'm gonna transition from a car salesman to not a car salesman and help us navigate this a little bit. And I think ultimately, you need to, it depends on what you're trying to get out of the experience. I'll first talk about this. This is when I talk to undergrads or other fellow grad students who might want to get into ManyBabies, there's often this misconception that this is a easy publication. It's an easy line on your CV, you do some work, and then it's all done. And in some ways that is true because of the credit model that ManyBabies adopts. You do get a line on your CV, but it's a line on your CV that involves like 100 authors. If your last name starts with like M, your name might not even, your name might be aggregated in like the ... right? So it's not, unfortunately, the current state of academia, if you want to stay in academia, multi-author publications are not weighted nearly as heavily as if you took all that time and you focused on a new project in your lab and get first authorship. You can get first authorship if you lead, but again, it comes with a tremendous amount of work, and it's likely more work, speaking from personal experience, many times more work than if you just do a project in your own lab. So if you're just trying to get a line on your CV, ManyBabies is not the path of least resistance, so this should not be the motivation. However, ManyBabies has a lot of things that you can get out of. The first reason is that this is a really incredible networking opportunity, especially if, like me, you're a bit of a hermit and an introvert and you don't like to talk to people. ManyBabies forces you to talk to researchers all around the world in an effort to coordinate, and even if you're just contributing data collection, you have to talk to leads, you have to figure things out, and you come to conferences and you meet all these people that you only see on Zoom calls. It's honestly an unprecedented opportunity to expand your network, especially if you're at an institution that's, for example, not an Ivy institution. You don't have those existing networks that you can tap into. ManyBabies is a great way to kind of get your foot through the door. The second reason is, like I mentioned, lots of new skills. Every PI has their own specialized set of skills, and that's, for most of you, that's the reason why you decided to work with them. But maybe along the way, there's new skills that you want to pick up that your PI can't teach you. And ManyBabies is your way of getting into that. For example, if you do a lot of, your PI's lab does a lot of eye tracking work, but not pupillometry, and you're very interested in pupillometry, there are experts that do pupillometry that you can tap into if you join some interesting projects. So that's a great way to kind of diversify your skill set. And finally, there are some leadership opportunities if you want to get experience doing stuff like that. ManyBabies has a governing board where once a month they meet, they talk about ManyBabies, they talk about the infrastructure, they make some executive level decisions, and starting from 2 years ago, they have made an active effort to have 2 student advisors that are non-postdocs, so they have to be eligible, they're only eligible if they're existing PhD students, on that governing board, giving their input, giving their advice, and giving their perspective. I, along with Mary Beth Neff, who I should have listed here, was the first generation of student advisors. It was a great experience to see what it's like running an organization of that size and the decisions and the discussions that go into it. And then now Magda and Quinn are the second generation. For equity reasons and for diversity reasons, these are only 1-year terms, so it's fairly low commitment, but it's a great way to gain some insights. As you can see, in June, our 2 amazing student advisors, their terms will be expiring. If you're interested in these roles, again, experience with ManyBabies, not a prerequisite at all. So if you already have a lot of experience or some experience with project management, with these like management level positions, highly encourage you to apply and get some insight and get involved in ManyBabies from the top down. Okay. Selfishly, there's reasons where we want you to join. Like I mentioned before, a lot of ManyBabies projects emphasize horizontal diversity. I don't know if this is the correct term, but this is the way I visualize it, so I'm going to call it that. Horizontal diversity in that we are getting data and participants and labs from different regions, not just North America, not just Europe, so we get diversity that way. But just as important as horizontal diversity is vertical diversity. It shouldn't just be the people who have tenure doing the work, because they come in with a different set of perspective, with existing theories that they already have. Younger people, I shouldn't say younger people, I'm also an old early career researcher. People early on in the career might come in with very different opinions, and ManyBabies is, we really want to make sure that we get as much vertical diversity as possible, not just from graduate students, but even undergrads might bring in something really fresh, because they're, I don't think contaminated is the right word, but they're less influenced by what they have already, what they already know from the significantly fewer years of research that they have done. And this is especially important when it comes to policy and infrastructure. We want to hear from you. We want to hear from people who the policies actually affect. And that's it. I want to stop there, so we have some time for questions if you have any.
Thank you very much, Francis. So super cool. I learned a lot of good things about how ManyBabies can be seen. That's really cool. Any questions for Francis or anyone else? Yeah?
I have a more practical question about how it works in terms of like all the different labs and stuff doing different data collection. How does it work with ethical approval and those kind of practical aspects that are a bit of a challenge working across even just 2 labs with the same research group?
Yeah.
How does that work?
Imar and I are having flashbacks. So it is, in short, it's a bit of a nightmare. And it requires a tremendous amount of back and forth, especially dealing with different regions, right? The reason why Ingmar and I let out a collective gasp or sigh is, as part of ManyBabies 4, we really wanted to make sure we can share video recordings of the infants. And in European institutions specifically, for very good reasons, I don't mean this as a diss or anything, they are very, very protective of that data. And navigating ethics is 10 times more difficult, as you can probably imagine. I don't really have good advice aside from reaching out early, because you can have all your beautiful stimuli in place, you can have everything, all your infrastructure set up, and the university will kind of have a death grip on you and not let you do the studies. Yeah, so unfortunately, I don't have a great answer to that, except for you are totally right, that is tremendously, tremendously difficult.
And
That's for video data, right?
Yeah.
I mean, so that is the specific case of video data. If you have anonymous, just looking time data, of course it's going to be much easier for labs to pass their ethics approval. And the general approach, I think, is that labs get their own ethics approval, lab is responsible for its own ethics approval.
And we then require them to tick a box that says I have ethics approval, or upload their actual form or document to help others. But this is responsible for each lab is responsible for that.
I actually want to add to that. So there is a another approach that we actually did in MB4 that has helped quite a bit, which is having an umbrella ethics, where you have the leading institution do a much more stringent ethics application saying we are doing this large-scale project, and this is where we're going to kind of volunteer storage space for all of this data. Here are all the rules that we're going to follow. And once that's pushed through, contributing labs can use that as like a point of reference to get their own ethics approval, saying like, hey, look, this institution, like UBC already got this big ethics approval through. All it will take is for us to also be added to that ethics approval. None of this data, all the data will be anonymized, and it will all be stored at UBC. UBC is legally responsible, and that has been tremendously helpful in expediting the process. It, of course, comes with a certain degree of risk and a lot more work on the leading institution's part. I am still navigating that, but it is one potential approach like that can actually kind of be in parallel to having institutions get their own approval.
Another example is that it also can drive innovation. I guess that's, so one thing this partially attaches this topic is the ManyBabies Demographics Project, where I think boards complained that we don't ask about race in our country, for example, and this led to the more bigger question: what is there a core of demographic information we can collect to compare data sets from different countries? Is this feasible at all? So this is a whole line of ManyBabies projects, I would say. Another example is with video sharing for the many webcams thing, because we had webcam recordings of the toddlers at home. And for example, labs in, I don't know, you use your own setup, but a lab in Mexico City used the setup from Munich. So the code and the servers which are based in Munich. And they didn't get ethical approval for their videos to be collected in Mexico, but kind of recorded or stored temporarily in Munich and then be sent back. So Adrian, but he also is kind of a genius, he invented this many keys frameworks, he also named it. It uses like crypto technology, whatever, to encrypt the videos at the computer of the participant, send them in this encrypted way to our server. Then the lab in Mexico can download the encrypted video from our server, put in, I don't know, 30 digits password, and then they can see their video from their country. So it is collected somewhere else, but we never see the videos, so no ethical issues there. This is one example of how to deal with that. But a nightmare summarizes it.
Just to add one remark to that, I think what this shows is that the ManyBabies Project in that sense also drives some of the standardization processes that we want to go on in our science, right? Such as the demographics project, I think is a really great example of that. You know, we're talking amongst ourselves, like, you know, what are demographic variables that we really want to be collecting, and that drives innovation also in our talks with ethics boards, right? So our ethics board is quite strict about some of these things, and they say, you know, if a particular demographic variable is not part of your research question per se, then you're not allowed to even collect it, right? But then we are having this conversation following this demographics project. You know, it's actually necessary for all sorts of, like, you know, broader questions of our science, like are our samples representative, for example. For those sorts of questions, it's actually very relevant to have at least some basic demographic variables and to make it more acceptable to do, to collect those types of variables. So it opens up those discussions with our ethics board, for example.
Just to follow on that one, so that means that each ManyBabies project, you can contribute this data to the demographics project to say to the ethics board, we need these demographic data as well because we are going to analyze them. Is this how it works? Or is it separate?
So the demographic variables, yeah. So the MB demographics, I don't know much of the
Yes.
details, but they propose some standard list of demographic variables to be collected, and that we want to be part of each of the projects.
Yeah, maybe I can clarify what that. Oh, I have it. Yeah, I can clarify what that project actually is. So the MB demographics team doesn't actually analyze anything. The goal of the MB demographics team is actually to come up with a standardized way to measure these variables. It was largely inspired because across during MB1 especially, we noticed a recurring pattern of labs not measuring things that we once thought were already very standardized in the same way. And the best example of this is gestation and preterm. Different labs, turns out, they define preterm very differently depending on the region that they're in. And so that kind of spiraled into this discussion of like, okay, how can we come up with specific wording that can then be back translated into different languages that ask about the same construct in a way that is comparable across regions. So that's what the MB demographics team is primarily working on recently. The first paper from this team has recently been published, where we talk about here are the core, what we consider core variables of interest in developmental work. This includes things like ethnicity and gestational period and so on and so forth, and like developmental disorders and things like that. And the justifications for why these are core variables, and why we have arrived at this very specific way that we're asking participants to report these variables. Not everyone agrees that the ultimate product that we came up with is the standard, but we got to start somewhere, right? And we believe that this will be an iterative process as people's ideas of what race and ethnicity means has changed dramatically in the last 10 years, right? And as our understanding of what these variables mean change, so should the way that we ask these questions. And that's what the project's working on. So we don't actually analyze anything, but we want to come up with the instrument of measurement itself.
But then hopefully, once these projects actually adopt these standards, we will be able to analyze across the ManyBabies projects, for example, some of these basic questions about representativeness of samples, and also in many of the dimensions that are part of the standardized questionnaire, which we try to do across MB2, 3, and 4. But as the MB demographics was running parallel, yeah, I guess we ended up adopting different versions. But anyway, we're at least closer to standardization than we ever were before, I think.
Yeah.
So that's good.
Time is up, right?
Yeah.
Yeah. I never had 3 hours on a conference talking about the stuff I like. That's super cool. I hope you liked it as well. For me, so my resources are gone for today and tomorrow and Saturday probably. No, I can just sit and listen. So any questions, if you want to join, just email anybody. It will land in the right place. It's a great opportunity to meet people, to learn about the world, how stuff is done in different countries. If you're interested in the field and the people who are doing this, this is a great opportunity, a low-cost opportunity. Just jump in.
Yes, absolutely. I want to second that. I've learned so much from being part of ManyBabies, and I've met so many interesting people. So that alone is just very rewarding, next to obviously the hopefully very good science that we do as well. Well, thanks for joining us, and let's keep the discussion going over lunch or whatever. Thanks to all the speakers also. Thank you.